You can hopefully see that. Yeah.
Yes.
Yeah, we can.
Okay, good. Sorry, it's not ready yet. Let me just move a few things around.
I like the structure there.
Yeah, that's my little org file. So let me make a text quick.
I think you have the zoom window on the top left corner. Could that be the case? Yeah, that one.
Let me try and get rid of that thing.
Because what the zoom does is it overlays it for us so we can see what's behind it.
Right. How is that looking now?
I think that's a lot better. If you can minimize the stuff in the lower right corner, then I think we're perfect.
Yeah, okay. Let me try and get rid of that. Yeah.
Yeah, there we go.
Good enough,
perfect.
I suppose.
Yes.
Okay.
Thank you.
All right. Sorry about the initial technical difficulties. My name is Martin Baillie, and today I'm going to be talking about creating ephemeral or short-lived GitHub tokens via HashiCorp Vault. So on the agenda today, we're going to talk a little bit about the motivation. So why might you want short-lived tokens from GitHub? Then we'll talk, I guess we'll talk about what it was about that automation story with GitHub that gave me reason to write a Vault plugin. Yep, but ultimately this is a talk about a Vault plugin. So we'll go through the architecture of that plugin and how it works. But more importantly, we'll go through quite a detailed demo. I might skip some steps now, given it's the end of the day, and I actually think I've done too many steps. I was going to set up the plugin from scratch, but I guess we'll just leave that for now. The hope is with the demo, it will inspire some questions at the end if there's time. Okay, so we'll get straight into it. We'll start with GitHub's automation story. You might be familiar with it if you've ever had to try and talk to GitHub's API from outside of GitHub, or even inside GitHub, actually, if you've used Actions, but you're using some more advanced features of GitHub Actions. So it usually starts with a personal access token. These things, hopefully my browser pops. You might be familiar with this screen here, creating these tokens. So these tokens, they have pretty interesting characteristics. One of them for me that was a big bugbear is the permissions are super coarsely scoped. So inevitably you end up needing to give this one, which is the repo access. And by doing that, you've ended up granting full access to all of your private repositories, full read-write access, I should say. People can access pull requests, issues. Sorry, the token can access pull requests, issues, the full shebang. And if that token leaks, then someone else has access to all of that. Another less desirable characteristic of these tokens are they never expire. So in fact, the only way to get rid of them is to delete them from your user account. And yeah, they're tied to a user account. So quite often you'll find in organizations that users have tried to experiment with GitHub's APIs, or maybe they've actually invented a critical business process, maybe CI/CD agents, for example. They'll have created one of these personal access tokens against their account. So if that user then gets offloaded from the organization, perhaps because they've moved on from the company, that token goes with them and that critical business process breaks. Now to remediate that, normally an organization will create a CI/CD user. So that's just a machine user that consumes a license seat, so it costs a bit of money. But ultimately, you'll find you're in the same position, right? You've got a powerful user with long-lived access tokens that are just one leak away from, possibly some reputational damage to the organization. So apps are a relatively recent thing in GitHub. They represent a different way to integrate to GitHub and automate stuff. They have a much better permissions model. So if you contrast this view to the previous view, you can see there's so many more permissions. You can add and remove these individual groupings from the token, much finer grained. Another nice characteristic is these tokens expire after 1 hour. So, and you can't change that. So GitHub will expire those tokens after 1 hour, which is a good thing, right? But yep, another nice benefit here is you install it into the organization itself. You don't attach it to a user. And if you have many organizations under the umbrella organization, then you know, you can share it between them all. But yeah, they are a better automation story, but they are also more awkward to deal with as an end user. Firstly, there are some pretty sensitive private keys that are used as part of a larger token request flow, which, you know, I think this is perhaps pseudocode, but the general gist is you have to create, use the private key to create a JWT of a specific makeup, and you use that JWT to ask the GitHub API for an actual token. So I think the key message there is maybe there's a pretty sensitive private key needing managed. Okay. So this is a talk about a plugin, and I wrote a plugin maybe a few years ago to try and improve on this security posture with GitHub and to make working with an app easier. So the architecture of the plugin looks something like this. Firstly, you would install the plugin into your organization's Vault, or get your Vault team to do so. And then you mount the plugin at an endpoint, so GitHub, for example. Your users interact with Vault, they don't interact with GitHub. And those users can be machine users, so it could be a CI/CD agent like BuildKite, Jenkins, Argo CD, something like that. Or it could be a human user, maybe trying to do some experimental automation. Either way, they authenticate to Vault using the authentication methods chosen by the organization. So for a machine user, that might be, let's say, Kubernetes authentication or AWS IAM, for example. And for a human user, that might just be LDAP or perhaps an OpenID Connect identity provider. Point is they use the existing pre-approved settings that your organization has chosen. There's no need to deal with private keys and integrating to Vault. Integrating to GitHub, I should say. Anyway, so a request then looks like the user making a request to Vault, Vault handling that complicated JWT work process, you know, to get a token from GitHub. So it mints a JWT, passes that on to GitHub. It mints a JWT, I should say, using a private key that is now securely stashed in Vault, never to be seen again. Nice and a nice tight posture there. It uses that private key to get an actual token from Vault, from GitHub, I should say, and return it. And then the user can go about their merry way with that token. You're safe in the knowledge that that token will last at maximum 1 hour. Okay, demo time. Yeah, I'm always a fan of talks that have demos, so I thought I would maybe showcase some of the features of the plugin. The trick that I missed was I probably did too much setup, so I started writing out all of the steps for installing the plugin, how to get it, how to configure a GitHub app. But to be honest, the repository is pretty well documented. I guess we can leave that stuff as an exercise to the viewer. So what I might do is quickly breeze past a few setup steps. I was hoping to have done this beforehand, but no such luck. key thing is we're going to run a development Vault instance. So let me start one up on the terminal. And we're going to use this going forward. So that's a Vault instance there. It's Vault version 1.7, and we are just accessing it using the root user. Sorry, I'm moving fast through these slides. I promise I'll slow down once we get to the interesting stuff. Yep, enable the Vault plugin. You'll just have to trust me that the README in the website is pretty good. Last step is configuring the plugin using details I've got from GitHub. We'll be using a GitHub app from my own profile as part of this demo. Okay, configure the plugin, and I can confirm the settings are in place. Okay, we'll slow down a bit now, and we'll start to maybe use the plugin, and we'll see how all the different ways you can use it, basically. The first thing anyone's going to do really is get themselves a token. So the way they do that is they use Vault command, or they can use the API direct, I suppose. And they can do a read or a write against the GitHub token endpoint like this. All going to plan, I should have in Vault's tabular output format here, I've got the response from the plugin. So let's take a look at this. There's one critical thing here, that is the actual GitHub token. But there's some other interesting things to talk about. Yep, the token expires in 1 hour. But crucially for later parts of the demo, there's actually a Vault lease ID attached. So Vault, if you don't know, has an internal concept of leases, and you can use that to maintain the lifecycle of something that's being managed by Vault. Some of this other stuff is really payloads that are coming back from GitHub, and the Vault plugin just passes them on through. So what we're seeing here is I've got permissions to read the contents of repositories, to read metadata, to create pull requests, and to read single files. Yeah, so one thing that's worth noting is at this stage, this is an unconstrained token. So this token has access to the superset of privileges that the GitHub app has access to. That's still a massive improvement because it's a GitHub app. It's not a personal access token. So you can constrain what the GitHub app has access to. And I have done so. I've only selected 4 or 5 settings out of the 100 or so that are available. And yes, it expires in 1 hour. So just to set up some demo scenarios, I was thinking we would perform a few operations with this token. So I've got myself a token. Again, it's in my shell environment now. The first thing something might want to do with a GitHub token is probably clone a repository. So I've got a repository in my personal profile for this talk. It contains these notes, some of the images that I use and stuff like that. I've got it checked out here. This is what it looks like. There is a file in this private repository. Nothing interesting. It just has a sentence in it that says this is the contents of a file in a private repository. But the point here is if I was to open a shell and try to clone this private repository, we would expect it not to work. And thankfully it doesn't. So that repository is definitely private. If I was then to use the token in my environment to clone that repository, so same clone command, but this time I'm using HTTP basic authentication to tell GitHub about the token. And yeah, I'm just going to clone it to a temporary directory. All going to plan, that should work, and it did. So I cloned a repository using that token. So one other thing that you might want to do is actually use GitHub's API instead of using like Git remote operations. So in this case, I am going to use the token to read that demo file that I was just showing, but I'm going to read it via GitHub's API. So I'll go into plan. Yep, that should print out the contents of that file, which, as we know, is this file here. So that's us accessing a private repository and pulling out a single file using a GitHub token that was given to us from Vault. But yeah, as previously mentioned, GitHub app tokens, they last for 1 hour, which is a big improvement on the perpetual tokens that you get with personal access tokens. But as I was saying, there's a Vault lease attached. If we query Vault at the moment, we'll see the 2 tokens that I've created so far are in Vault, and these are the lease IDs. So you can also see this in the Vault UI. So if I was to sign in as root to Vault, there I can see those 2 leases that are still, they've got about 55 minutes left now, I guess, these leases. But something that Vault gives us on top of all of this is the ability to revoke. So we can revoke tokens earlier than 1 hour, and Vault will do the needful interactions with GitHub's API to tell GitHub to cancel that token on the user's behalf. So, oh, and another thing you can do with Vault is you can revoke all tokens managed in one shot. So a reason for doing that might be a security incident has forced you just to basically wipe all of the tokens that are currently in flight. So I thought I would show that happening in action quickly. You don't need to know what this incantation does, this JQ. The point is it's to show you the permissions that this token that's currently in my environment has with regards to GitHub. And then if we were to go back to the browser, pretend there's a security incident and revoke all tokens under the prefix, which we can see here. We should have seen some action in Vault's console, actually. So if I was to look for revoked, there we go. I can see the 2 tokens being revoked in Vault's backend. But then if I was to, just to round that out, if I was to try that command again, hopefully I should see, yep, bad credentials. So we've just used Vault to wipe potentially an entire organization's current in-flight tokens, which is quite powerful from a security operations perspective. Okay, so moving on with the features available in the plugin, it's possible for a user, a consumer, to constrain the tokens further. So they would do it as normal. They'd make a request to the token endpoint, but they can pass a parameters object. And that parameters object gets passed through to GitHub, basically. So you can, as a user, you can ask for a more constrained token, as you should do if you're practicing, least privilege access. So in this case, I'm now going to ask for a token that only has the permission of single file read, which should mean I can still use that token to read that single file, and that works. Okay, so that's the contents of the file. However, that other demo scenario where I try to clone the full repository, that shouldn't work now because I don't have any permissions on. I don't have any permissions on the token to allow me to do that. So same command as before, but with that new token here. Cloning to a temporary repository, I should get rejected, right? And that's worked. So the token I'm using has no permissions to clone repositories, so can't clone repository. Back to my slides. Yeah, so another thing we can do here is keeping that client constraint stuff in mind. we can actually force clients to request from Vault a token of a very certain makeup. And you can do that with a Vault policy. So if I was to lodge this Vault policy into Vault, it's basically saying, I require these two parameters, and these are the allowed values of the parameters. So the repository IDs must be this number, and the permissions must be pull requests equal to write. There can be no other requests sent to Vault when this policy is attached. So if we were to attach that to a user in Vault, you're probably managing your users differently using a different backend. But if we enabled the normal user pass backend, then and we attach that policy to a user called Martin, then that user Martin can only now make a request to the tokens, the Vault tokens endpoint, so this guy here, that looks exactly like that policy. So if the user Martin was to attempt to just read any token, so get an unconstrained token, they're going to get rejected. If they were to try and just ask for pull requests equal to write, but without the repository constraint, they're going to get rejected. If they ask for different permissions and so on. So only that exact incantation will get past Vault. So that's nice, but the most recent version of the plugin actually takes a lot of that cognitive overhead away from the end user. So there's a new concept called permission sets. This is similar to a Vault GCP plugin, I believe. And the way it works is you create a permission set. So a permission set is a special subpath under the main plugin path. You give it a name. We're calling it demo set here. And then you say what permissions you want that demo set to create tokens with. So in this case, I've created a permission set called demo set, and the permissions are only single file read again. So then the way you create a token from a permission set, very similar to how you would normally create a token, except you don't stop there. So you don't stop at the root path. You provide the demo set or the name of the permission set you're trying to get a token from. All going to plan, I should now get a token from that permission set. And then just to go back to our two sort of usage scenarios, if I use that token to get the contents of the file, we would expect it to work because that's literally the only permission that these tokens should have. I get the contents of the file. Then again, if I try to clone the whole repository, just to round out the proof, it should fail again, right? And it has. So that's great. We've now got a subpath that will return a token of a very specific permission model that the user doesn't have to think about, what do I need to make in my request? They just do as we did above, which is to read from the endpoint or write to the endpoint. Again, you would probably want to enforce that with policy. So the users that you want to allow just to have that single read file permission, you would attach a Vault policy to them. So as I've done here, and now that user Martin, he doesn't need to think about the different GitHub permissions he has to put in his request to Vault. He just asks for a token from the demo set. And that, if you choose, will be the only endpoint that he can call on the plugin. Timing is going okay, I think. Another feature of the plugin is it provides metrics. So they're available in the Open Metrics Prometheus exposition format. And so long as you have network access to your Vault, you should be able to query it and get Prometheus style metrics. And of course, you could wrap authentication around that endpoint if you so chose. The sort of metrics that come back are summaries and counters and gauges of the operations being performed by the plugin. So basically percentiles of how many tokens were created, how many of them were successfully created, were they constrained, were they not, that sort of thing. A whole raft of them. The plugin also has, let me get that in view. Jump into it, maybe might help. Plugin also just ships with a demo dashboard, basically, that you can choose to use, or you can use it for inspiration, maybe, as you make your own internal dashboards. It's probably worth mentioning that this plugin has, I'm aware of a number of companies that are using this plugin in production, or have been using it for a number of years. We're at version 1.1 now, and yeah, it's been pretty battle tested. So it does its thing, and it does it quite well. And it plugs a few holes in the GitHub automation story. I think we've got time for this one. This is a nice little way that you can use the plugin if you were so inclined. So it's actually possible to write what's known as a Git remote helper. We won't go into the documentation behind that, but essentially, for those that don't know, Git has a concept of porcelain and plumbing, and porcelain is what everyone would normally interact with. So that's your normal Git CLI. But the Git CLI is ultimately calling a series of hidden binaries that are still on your path. That's the plumbing. And often you'll find other porcelains created, so other user interfaces. For example, Emacs has Maggot, and I think there's a product from Atlassian called Source Tree or something like that. Basically, different ways of interacting with the Git plumbing. It's actually quite easy to build one of these yourself. So what I've done here is I've created a new Vault protocol to make Git operations transparently aware of Vault. So instead of going to git clone and then using SSH or HTTPS, you type in vault:// and some magic happens behind the scenes before the plumbing gets called. I've got a little proof of concept script here that implements that. I mean, it's not production grade, but it should highlight the feature that I'm talking about. I guess we don't need to go through this, but the gist of it is it conforms to the interface that Git is expecting. And in between calling the remote HTTPS clone command, this is a plumbing command, it intercepts the URL and changes it up. So it will take in a SSH or a HTTPS. It will take in a Vault and it will swap it for an HTTPS, I should say. And at the same time, it will modify the URL and it will call out to Vault, get a token, and slide that into the basic authentication of the URL. It'll then pass that onwards to the Git plumbing. And after everything's done, it actually revokes that token. So I've got that tangled into a file here. And we could give it a shot just quickly to round out the demo. Let me get to the terminal that I was on. So if I was to go back to that clone command, that very first clone command, that's just an attempt to clone a private repository. We know that shouldn't work, and it doesn't. So if I was to swap that to Vault, hopefully some magic will happen. Yeah. So that's that interception going on. So we have intercepted the URL. We've made a request to the Vault plugin. We've got an ephemeral token back. We've then let the Git do its thing. And then at the bottom here, we've revoked that token again, now that the job is done. So that's like an instantaneous use of a permission token and then a canceling of it. Okay, get back to the slides. I think that's it. Yeah, that's all I had. Thanks.